In this lecture, we are going to learn about Hamming code generation, and error detection and correction using Hamming code. So, Hamming code not only provides error detection but also identifies which bit is in error so that it can be corrected. So, Hamming code is an error detection and correction code, but the parity is an error detection code. And Hamming code has more than one parity bits located at certain locations in the code. So now we will see how to generate a Hamming code. So for the generation of Hamming code, the first step is to find out the number of parity bits. As I told you, Hamming code has more than one parity bits. So first we need to find out the number of parity bits. So the number of parity bits p is determined by the relation 2 power p greater than or equal to x plus p plus 1, where p is the number of parity bits and x is the number of information bits. And we need to find out the number of parity bits p by substituting values in this equation using a trial and error method. Now the second step is to find out the locations of parity bits. So the locations of parity bits are the positions numbered as the power of 2. That means 2 power 0, 2 power 1, 2 power 2, 2 power 3, etc. That means 2 power 0 is what? 1, 2 power 1, 2, 2 power 2, 4, 8, 16. That means in these locations we need to place the parity bits, and in the other locations it will be the data. That means if there are 7 bits, total 7 bits are there in the Hamming code, then the 7th bit will be data, 6th bit will be data, 5th bit will be data. But what about the 4th bit? 4th bit means it is a power of 2, right? 2 power 2, power of 2. That will be the parity. Now 3rd bit will be data, 2nd bit. What will be the second location? Again it is a power of 2, 2 power 1. So that will be parity. Then first location B1. So first location is also a power of 2, 2 power 0. So that also will be the parity. So the powers of 2 locations having the powers of 2 are the parity bits, and the remaining will be the data bits. So if there are 7 bits in total, first location, second location and fourth location will be the parity, and the remaining will be the data. Now the next step is to assign values for the parity bits. For that purpose, we need to make a table here, in that the first row is bit designation, then bit location, binary location number, information bits and the parity bits. So in the bit designation, as I told you, the powers of 2 locations will be the parity and the remaining will be the data. So for example, we are taking 7-bit Hamming codes, total 7 locations are there. So the 7th location will be data D7, 6th location will be data D6, 5th location will be data D5, and 4th location, because it is a power of 2, this will be a parity P4. Then 3rd location is D3, and second location again power of 2, so that will be parity P2. Then the first location again power of 2, so that will be the parity P1. So the bit designation for a 7-bit Hamming code will be P1, P2, D3, P4, D5, D6, D7. Now the bit location, just we need to write the locations 1, 2, 3, 4, 5, 6, 7. Now next we need to write the binary location number. So binary location number, nothing, we need to write the binary of these locations. So what is the binary of 1, 0, 0, 1, then 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Next we need to write the information bits and then the parity bits. Then the combination of information bits and the parity bits will give the Hamming code. So first we will see how to assign value for the parity bit P1. For assigning values for P1, understand clearly, this is the binary location for P1 001, where the LSB is 1, or we can say the first bit is 1. And where all we have the first bit as 1, in 2 the first bit is 0, but in 3 first bit is 1. So 3, here also first bit is 0, and but in 5 first bit is 1, so 5. In 6 it is 0, in 7 it is 1. So we need to check the locations where all the LSB is 1. That means location number 1, 3, 5, 7. So for assigning values for P1, remember we need to check the locations 1, 3, 5, 7. Why 1, 3, 5, 7? In the location 1, 3, 5, 7, the first bit is 1. Here 1, here LSB is 1, LSB is 1, in 7 also LSB is 1. So that is why we are grouping these locations together. Now for assigning values for P2. For assigning values for P2, we need to check the locations 2, 3, 6, 7. Why 2, 3, 6, 7? See in P2, 2. Binary of 2 is what? 0, 1, 0. the second bit is 1. Okay, now we need to say where all in other location the second bit is 1. In 3 the second bit is 1. Then we have in 6 second bit is 1. In 7 also the second bit is 1. So that is why we are grouping the locations 2, 3, 6, 7 together for assigning values for P2. Now we have one more parity bit which is P4. Now for assigning values for P4, what is the binary of P4? 1, 0, 0, where the third bit is 1. Now we need to check where all we have the third bit as 1. Now here in P4 third bit is 1, in P5 also third bit is 1, in P6, P7 also third bit is 1. That means M must be is 1. So we have to group the locations 4, 5, 6, 7 together for assigning values for P4. With an example, we can understand all these steps clearly. So here is an example to generate a Hamming code for the data 1011 for even parity. So first step is to find out the number of parity bits using the relation 2 power p greater than or equal to x plus p plus 1, where x is the information bits. So the given information is 1011, so x is equal to 1, 2, 3, 4, x is equal to 4. Now we need to find out the value of p using a trial and error method. So first we need to put p equal to 1. Substitute in this equation 2 power p is 2 greater than or equal to x is equal to 4 plus p equal to 1 plus 1. This equation is not getting satisfied. That means p is not equal to 1. Next we need to put p equal to 2. If you are putting p equal to 2 in this equation, this relation will become 4 greater than or equal to 4 plus 2 plus 1. That means p is not equal to 2. Then we need to put p equal to 3. If p equal to 3, 2 power 3, that means 8 greater than or equal to 4 plus p equal to 3 plus 1. So here this relation is getting satisfied. That means p is equal to 3. So we found that the number of parity bits are 3. That means parity bits are 3, information bits are 4. So in the Hamming code, total number of bits are 4 plus 3, 7. Now we need to make this table. In that, first we need to write the bit designation. Total 7 bits are there. Powers of 2 will be the parity and the remaining will be the data. That means first location, second location, fourth location, P1, P2, P4 are the parity bits and the remaining will be the data D3, D5, D6, D7. So how many data bits are there? D3 1, D5 2, D6 3, D7 4. 4 data bits. And how many parity bits are there? P1, P2, P4. 3 parity bits are there. Next we need to write the bit location. Just we need to write the location numbers here 1, 2, 3, 4, 5, 6, 7. Then we need to write the binary of the location numbers. So binary of these locations we need to write. For 1 it is 001, then 010, 011, 100, 101, 110, 111. Then we need to write the information bits. So the given information is 1011, then that we need to write here in place of the data bits. So first it is D7 data, we can write the information here. Then we have D6, again that is data, so writing it as 0. Then next is data, D5, we are writing the data here. But the next is parity, so no need to write here. And the next is data D3, so there we need to write the information. So the information we need to write in place of D7, D6, D5 and D3. Next we need to find out the values of the parity bits P1, P2 and P4, then we need to write here. So now we will see how to assign the values for the parity bits. So as I already told you, for assigning values for P1, we need to check the locations 1, 3, 5, 7. Why 1, 3, 5, 7? In the locations 1, 3, 5, 7, the first bit is 1. So here 1, 3, 5, 7, the first bit is 1. So we need to check the locations 1, 3, 5, 7 for assigning values for P1. So now we will see what is there in the first location. In the first location, nothing is there. So leave it. In the third location, we have 1. So writing that 1. Then in the fifth location, we have 1. Writing that 1 here. Then on the seventh location, we have 1. That also we are writing here. So in the first location, nothing. But in 3, 5, 7 locations, we have 1, 1, 1. Now we got the binary word 1, 1, 1. For that, we need to assign the even parity bit. Why even parity bit? We want to generate the Hamming code for even parity bit. So what is the even parity bit for the binary word 1, 1, 1? That is 1. Why we are getting 1? Here number of bits are 3, which is an odd number. To make it as even, the even parity bit must be 1. So that is the even parity bit for the value P1. Now we are going to see how to assign values for P2. For assigning values for P2, we need to check the locations 2, 3, 6, 7. Why 2, 3, 6, 7? In the locations 2, 3, 6, 7, we have the second bit as 1. See here, in 2, the second bit is 1. In 3 also, there is second bit as 1. Then in 6, second bit is 1. In 7 also, the second bit is 1. So that is why we are checking the locations 2, 3, 6, 7. Now we will see what is there in the second location. What is there in the second location? Nothing is there. Then on the third location, we have 1. So writing that 1. Now on the sixth location, 0. Writing that 0. Then on the seventh location, 1. That also we are writing. So what the binary word we got? The binary word we got is 101. For 101, what is the even parity bit? Here the number of ones are 1, 2, 2, which is already an even number. No need to make it as even. So the even parity bit will be 0. So now we will see how to assign values for P4. For assigning values for P4, we need to check the locations 4, 5, 6, 7, where the third bit is 1. So here on the fourth location, third bit is 1. Fifth location, sixth location, seventh location, the third bit is 1. That is why we are grouping these locations together. Now you tell me on the fourth location, there is nothing. But in the fifth location, we have 1, so writing that 1. Then on sixth location, 0, writing that 0. On the seventh location, 1, again we are writing that 1. So what binary word we got here? 101. Again for 101, what will be the even parity bit? Here the number of ones are 1, 2, 2. That is already an even number. So the even parity bit will be 0. So we got all the three parity bit values here. We have three parity bits P1, P2, P4. P1 is equal to 1, P2 is equal to 0 and P4 is equal to 0. Now we are going to add these values in our table. So the parity bits are first P1, we got it as 1, then P2 that is 0, then P4 that is 0. So these are the parity bits values. Now how we can get the Hamming code? Hamming code is the combination of this information along with this parity. So here the information is 1, here it is 0, here the data is 1, then here it is parity bit value is 0, and here is data is 1, then we have parity 0, then P1 1. So the generated Hamming code is 101010